I think the best example, you are moving on a bike on a straight road. Okay, there's a road. Just simple examples. Huh? This will really help you a lot. Huh? So, and this is your car. It will move with a constant speed 40 kilometers per hour along a straight line. How it will move? Along this straight line. It will not take turn. So this is straight road. So nothing but I can say that this car is describing uniform velocity motion. Very simple. Later on we'll bring the definition. You just take a car. There's a straight road, and if it is moving along the straight road with a constant speed, the speed will not increase, not decrease. Then I can say the car is describing uniform velocity motion or uniform speed. Speed means again the magnitude will not change. So this is the best example of the uniform. Or car, not that bike. Okay, the bike also. 40 kilometers per hour, and the bike is moving along a straight line. It will not change the direction. The straight road is there. So constantly it will continuously to move with a 40 kilometers per hour. Then I can say the bike is describing uniform velocity motion. So in uniform velocity motion, what actually happens? The body covers equal displacements in equal intervals of time. For every 1 hour, how much of distance it will cover? 40 kilometers per 40 kilometers. So you can start giving the thing. So t equals 0, it is here after some time t. Then for every 1 hour, let me go for separate. So this will be your bike. Car only I'll draw it. Easy for me to draw. This will be car. So it is at s equals 0, 40 kilometers. This distance, this will be 80 kilometers. This will be 120 kilometers, 160 kilometers, 200 kilometers, and this will be 240 kilometers. T equals 0, it is here. After 1 hour, it will be here. After 2 hours, it will be here. After 3 hours, it will be here. After 4 hours. So what's happening? For every 1 hour, how much of distance it will cover? 40 kilometers. So here is what, like the time is how much? 1 hour. 1 hour. 1 hour. 1 hour. How much of distance it will move? 40 kilometers. Next 40 kilometers. Next 40 kilometers. 40 kilometers. This car only will move. I can move the car. Okay, not possible. You have some graphics somewhere in books, no? You can some in internet if you want, you can try that. So for every 1 hour, it will cover 40 kilometers. This is the example of uniform velocity motion. I think this is very simple for you. Even anybody can understand. Not practically possible. Huh? We don't get a straight road of 240 kilometers. On paper, I'm showing it. Maybe 10 kilometers or 1 kilometer, you can see that. So reduce that to meters, you can experience this uniform velocity motion. The speed of the car remains same and the direction also remains same. So that will become uniform velocity motion. Both the speed and direction should not change. This is the example of uniform velocity motion. So how you define? What are the basic features of uniform velocity motion? If the velocity of particle, if the speed and direction, if the magnitude, and direction of motion is the magnitude and direction of velocity, you write it. Velocity of a particle. Particle means here car. Particle remains constant. It is said to be moving with the particle is said to be moving with uniform velocity. Said to be moving with uniform velocity. Next, the body covers, the particle covers the particle will have equal displacements in equal intervals of time. Will have equal displacements. This is very, very important, in equal intervals of time. This is a very basic feature. So this is about the there's a path. What is this red color? Path of a car. Okay, this is what. Okay, graphically, can we represent? Okay, next, because the graphs are something very important. No? Every time we can't draw. Yes, the graph also we can. We have to show that equal intervals. Okay, this is our curve. I think I'll redraw it. Because I have to follow the scale. Now we'll draw it. I have graph paper. Again, we have to change complete. That will be. This will be sufficient. you can see no. This interval 0. This is a time 1 hour, 2 hour, 3 hour, 4 hour. This will be 40 kilometer, 80 kilometer, 120 kilometer, 160 kilometer. This will be position. This will be time. So the body covers, it will have equal displacement in equal intervals of time. Then such motion is said to be uniform velocity motion. Okay, now what about uniform speed? How we define? If a body covers equal distances in equal intervals of time, it is said to be uniform speed. Okay, there's a one more, same thing. So because most of the problems we'll discuss about the uniform speed also. So what about the, okay, let's come for this one. We have uniform velocity. So let's get into the, what will happen to average velocity and instant velocity. The instant velocity. So in uniform velocity motion, some features, once again, let me add up all. in uniform velocity motion, already have these things. Let me summarize all at a stretch. Copy. This not needed. The first thing. The next again. In uniform velocity motion, the particle will have equal displacements in equal interval of time or equal distances in equal interval. Both are same. This one. The velocity in uniform motion does not depend upon the interval of on the time interval. So here also the velocity in uniform motion is independent of choice of origin also. So what is a uniform velocity motion? It's a body moving in a straight line with a constant speed. Example of this: body moving along a straight line with constant speed. Now, what about the average and instantaneous values? Both will have same thing. The average velocity and instant velocity will have same values in uniform velocity motion. So like this, we didn't understood. If a body moves with 10 meters per second, I think, and it's a constant, then you calculate average velocity for any interval. It will become equal to instant velocity only. For 1 second, it will move 10 meters. Not able to understand. I'll give an example. This is S equals 0, T equals 0. In 1 second, it will cover 10 meters. In the next second, it will cover another 10 meters, 30 meters, 40 meters. So what is the distance covered? You can see here. This will be 10 meter, 10 meter, 10 meter, 10 meter. Now what about the time interval? 1 second, 1 second, 1 second, 1 second. You calculate average or instant velocity. Both will be same, no? For 0 to 3 seconds, you calculate what is the displacement, 30 meters. Then what is the time taken? 3. Calculate average velocity. It will be again 10 only. So therefore, if a body moves along a straight line, this is a path. If a body moves along a straight line, and if it's moving with a constant speed, then its average velocity and instant velocity will have same values. So I agree this. So already we are discussing about the instant velocity and average velocity previous class. Here I'm trying to correlate with instant velocity. So the uniform velocity motion is something very important. We are going to discuss the numericals now based on this uniform velocity motion. So till now, I just gave all the description, the theoretical ideas of the uniform velocity, the instant velocity, average velocity, incident velocity, then uniform velocity motion. All these things is what we have covered. Okay, this is about the thing. So in the next class, what we do is like we will take the help of the numericals on uniform velocity motion. I think this will be the very interesting part of all this today. What all I discussed, no? How to calculate incident velocity. Let me just summarize. There are two methods are there. Either take help of mathematical tool differentiation, directly substitute, calculate the first derivative of that function, because how you define incident velocity, rate of change of displacement, ds by dt. This will be much easier. Or else what you should do, you have position versus time graph, plot a curve, then corresponding to 5 seconds, you locate a point, draw a tangent, calculate the angle made by tangent with horizontal. Tan theta will give instantaneous velocity. This is a method one. This is like a using geometrical instruments. This is using differentiation tool. I think this will be advice. This will be using geometrical tools. This is what mathematical tool. Tell me which one you will prefer. Definitely this one. So therefore, if you learn differentiation tool, it will be much easier. You can better. Okay, best example is today you can try with your bike. So the speedometer of bike will indicate the instantaneous speed. This is one simplest example I'm giving it. Okay, now we'll